Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 3 to the power of log n plus 9 to the power of log n equals to 27 and its whole power log n. So now we will solve this problem for the real values of n. So the very first thing we are going to do is, here first we will rewrite this equation as, and here you have 3 to the power of log of n plus, here you have 9 and we will write it as 3 squared and its whole power log of n equals to, here you have 27 and we write it as 3 cubed and its whole power log of n. So now in the next step we will use here the nice exponential law on left and right hand side, and you know that if we have a to the power of m to the power of n, it is equals to a to the power of n to the power of m equals to a to the power of m times of n. It means that if you can just interchange these two exponents, then it cannot be affected our final answer. So that here we need to interchange these two exponents and these two exponents as well. So now first I can interchange these exponents in the left hand side, so that its left hand side will becomes in the form of 3 to the power of log of n plus 3 to the power of log of n and its whole squared. Here I can just interchange these two exponents. Similarly we will interchange these two exponents as well, and you write 3 to the power of log of n and its whole cubed. And now in the next step we will convert this nice exponential equation into the cubic form, so that in order to change this into the cubic form we will just make some substitution here, and we can just take y equals 3 to the power of log n. So now you can just substitute y equals 3 to the power of log n in the above term, and you will get its output in the form of here you have 3 to the power of log n, it will becomes y, and plus here you have 3 to the power of log n, and when we put it y here it will becomes y square, and this whole equals to y cubed. So now here I can just simplify this term, and we move all the terms in the left hand side to the right hand side, and it will becomes y cubed minus y squared minus y equals to 0. So now you will here see that we have y be the common factor on each term, so that we will take common y here, and you get y times of y squared minus y minus 1, and this whole equation equals to 0. So now here we have two cases. The first case is you take y equals to 0, and the other case is you take y squared minus y minus 1 equals to 0. And now we will back substitute the value of y, and here you have y equals 3 to the power of log of n. So when you can put here, it will becomes 3 to the power of log n equals to 0. So here you see that in the left hand side we have an exponential function, and you know about exponential function, it cannot be equals to 0. Exponential function always gives the value greater than 0, so that it is not possible. So we will reject it this case, and now we can just proceed here this case only. So in this case first I can find the values of y by using the quadratic formula. So here we have a equals to 1, b equals to minus 1, and c equals to minus 1, and our quadratic formula is y equals to minus b plus minus b squared minus 4 times of ac, and this whole over 2 times of a. And now you can just put all the values of a, b and c in this nice formula, and you will get its output here. So when you put the value of b here, and you have b is minus 1, when we can put here, so this minus and minus will becomes plus 1, and plus minus we have b square, and b is minus 1 and minus 1 square is plus 1, and we have 4 times of a is 1 and c is minus 1, so this minus and minus will becomes plus 1, and 4 times of 1 is 4, and this whole over 2. So now we will simplify the terms, and you get here y equals 1 plus minus square root of 5 over 2. So here we have two cases. Now we can break this plus minus value in two cases, and we will write this as y equals to 1 plus square root 5 over 2, and its other value is y equals to 1 minus square root 5 over 2. So now here you see one thing is that when we put the value of y here, you see that value of y is 3 to the power of log n equals to, now we can first divide 1 plus square root 5 over 2, and you will get its value is 1.618, and when you can put here then you get 3 to the power of log n equals to 1 minus square root 5 over 2, and when you use calculator and you get the value of this expression, then you can easily see that this value is less than 0, or we say that it is negative. So our left hand side is exponential function, and I can already explain that exponential function is always positive, so it cannot be equals to negative value, so that we will reject it this case, because it is not possible an exponential function equals to some negative value. And now we will just proceed here this case only. So in order to find the value of n, we will just take log on both of the sides. So when you take log on both of the sides, then you will get here log of 3 to the power of log n equals to log of 1.618. So here we apply the property of log, and we can make its exponent in the front of this log, and you write log n into log 3, and it is equals to, now we can find the value of log 1.618 by using the calculator, and you will get 0.2089. And now we move this log 3 in the right hand side, so you will get here log of n equals to 0.2089 over the value of log 3 is 0.477 and 1. And now we will divide these two terms, and you will get here 0.4380. So in order to find the value of n, we have in the left hand side we have log n. So in order to remove this log, we will just take the anti-log on both of the sides. So when you take anti-log on both of the sides, we will write it here e times of log n equals to e to the power of 0.4380. So here you see that this log and anti-log are cancelled by each other, and we will finally get the value of n is e to the power of 0.4380. So this is our final answer of this problem, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.